Good morning. Yes, we can hear you. Just
Okay.
fine.
Thank you very much. Just to be sure that my
Yes,
setting
yes,
is.
yes.
Thank you.
You're welcome.
Good morning. Welcome to the ICCSA conference. In a few minutes, we will be ready to start this session. Thank you for your participation.
Good morning.
Good morning.
Good morning.
Everyone, we can start with the first city psychology and planning session. I saw that all the speakers are here. I saw Anastasia, Maria, Liliana. Best regard to everyone. And the first speaker, Maria, the first presentation will be done by you or by Felice?
By Felice, Beniamino.
Maria,
Do you hear me?
I don't.
We can't hear you.
Hi, sorry, good morning. I present the first.
Okay, perfect. Okay. First presentation is a spatial pattern of urban areas areas that derived from download scale satellite observation. Okay. The paper is has been the authors are Maria Danesi, Felice Perciante, and Rosa La Saponara.
Can I go?
Yes, yes, of course.
Okay. Good morning, everyone, and thanks for you for giving me the opportunity to explain our research. The ongoing environmental emergency accelerating the degradation of cultural heritage, primarily due to increased the concentration of atmospheric pollution, such as CO, SCO2, and NO2, especially in urban area characterized by high buildings density, traffic intensity, and limited green spaces. In interaction with the environmental factor, for example, humidity, temperature, wind, this pollution contributes to material deterioration process, including stone alteration and metal corrosion, thereby compromising the structural integrity of heritage assets over time. Given the strong spatial variability of pollution distribution driven by environmental and anthropogenic factors, high resolution mapping is essential for effective assessment and prevention strategies. Ground-based monitoring networks, for example, ARPA, provide reliable but especially spatial data, while EOT sensor network, through more distributed.
We still see the first slide. Is it correct? Or
Yes.
Okay, sorry.
I changed. Satellite observation, particularly from Sentinel-5P Tropomi mission, Science 2018, offer global and daily high quality data, but are limited by coarse spatial resolution and data gaps. To address use limitation, this study proposed a machine learning-based approach that integration heterogeneous multi-source data to reconstruct missing value and enhance spatial resolution by leveraging environmental, morphological, and anthropogenic variable. Additionally, a dedicated index is introduced to quantify cultural heritage exposure and identify critical spots, supporting monitoring, decision-making, and conservation planning. The case study is a complex urban context rich in cultural heritage. The municipality of Rome, characterized by potential critical environmental conditions. In this context, urban morphology plays a key role in influencing the distribution of pollution, thus justifying the choice of a city as a case study. In addition to urban morphology, the distribution of environmental parameters and consequently of pollution is closely related to the city geographic configuration. This study uses Sentinel-5P data for the CO and O2 and SO2, characterized by daily observation and spatial resolution of 3.5 to 7 kilometers, representing atmospheric vertical column details. Pollution distribution was modeled using both static variables, morphological and anthropogenic, and the dynamic environmental variable. Morphological data were derived from ADEM, resampled to 500 meters, while anthropogenic factors included the population and build-up density, GHSL, and road and density from OpenStreetMap. Environmental variable compares the climate data, temperature, pressure, humidity, wind, solar radiation from Era 5 land, precipitation from CHIPS, and land cover of a dynamic world, and vegetation condition from NDVI of Sentinel-2. To account for pollution formation process, environmental conditions from the days preceding satellite acquisition were used. Cultural heritage data were also sourced from OpenStreetMap. Processing and modeling were performed in Google Earth Engine using a random forest algorithm to reconstruct missing data and enhance spatial resolution. Map algebra techniques were then applied to compute statistics and estimate exposure, resulting in an integrated workflow that combined satellite data, environmental variables, and machine learnings to generate more detailed and reliable air pollution maps. Temporal trends in pollution concentration were analyzed using ARPA-Lazio data, 2018 to 2025 from 11 monitoring stations in Rome, revealing clear seasonal patterns. NO2 and CO peak in winter due to increased emission from the heating and traffic combined with meteorological conditions that favor pollution stagnation, while SO2 show high concentration in summer. Based on these trends, January was selected for NO2 and CO analysis, and July for SO2 to focus on periods of higher environmental pressure and better capture spatial pollution patterns and cultural heritage exposure. Subsequently, explanatory variables were spatially harmonized to a 500-meter resolution for urban scale analysis. High-resolution static layers, DEM and DVI population density, build-up density, were upscaled using a mean focal function, while categorical land cover data, dynamic world, were processed using a majority focal function. This variable, representing the morphological, environmental, and anthropogenic characteristic influencing methodological condition, were used as input data set for the downscaling and environmental parameters derived from Era 5 and CHIPS data. A random forest model with 100 trees was applied, producing a 500-meter resolution dataset that preserves the information content of the input variables while improving the representation of local gradients. Following dataset preparation, missing values in atmospheric column of the free pollution were imputed using a random forest algorithm implemented in Google Earth Engine, resulting in a continuous pollution map and an enhanced spatial resolution of 500 meters that you can see on the image. Model performance was evaluated using RMSE and Pearson correlation coefficient. The low RMSE value and high correlation coefficient that you can see in the table demonstrate a strong predictive capability, ensuring consistency between downscaling output and original satellite data, thereby confirming the robustness of methodology. High-resolution pollution raster were used to compute pixel weights, monthly average and maximum values to map algebra. Average values represent background pollution associated with long-term degradation process affecting cultural heritage, while maximum value capture episodic peaks linked to short-term high-intensity exposure. Where combined, use enable a comprehensive assessment of heritage exposure. A normalized Euclidean distance for cultural heritage sites was incorporated into the Heritage Exposure Index, defined as you can see in the slide. The index ranges from values near 1, high concentration close to heritage, to values near 0, low concentration far from heritage, with intermediate values representing a mixed condition. Each EA values were classified into 5 quantile-based categories to map exposure severity. Results reveal different spatial patterns. CO show high concentration in central room, affecting a large proportion of CH. NO2 exhibits similar trends linked to traffic and urban affected urban density. SO2 present a lower and more dispensed concentration, likely due to more distributed emission sources. The study developed a scalable approach to assess cultural heritage exposure to air pollution by integrating remote sensing, machine learning, and spatial analysis. The HEA index combined the pollution concentration and heritage location, identifying CO and NO2 as the main exposure drivers, with a minor role of SO2. The method supports decision-making for monitoring and conservation and can be extended with the addition of pollution, long-time series, and material vulnerability factors. Thank you for your attention.
Any question from the audience online or in the room? No? Felice, have you considered the coherence of this data with the data surveyed on land?
Yes.
Yes.
The use of the soil and the cover of the vegetation, different cover of vegetation.
Other questions? If there aren't other questions, we can thank you, Felice. Thank you for your interesting presentation. We can move to the second speaker, Maria Danese, from Open to Build Surfaces, Spatial Analysis, Remote Sensing for Photovoltaic Energy Computing. Maria Danese and Canio Sabbia Alfieri from National Research, Italian National Research Council. Maria,
Can you hear me?
yes. Yes. Perfect.
On my screen. I hear a negative.
Okay, we can see your screen.
Okay.
You can start.
Okay. Good morning, everyone. Thank you for your presentation. Maria Danese, and we will present the study entitled From Open to Spaces, Spatial Analysis Sensing for Photovoltaic Energy Computing. This work investigates whether photovoltaic systems. Yes?
We don't hear you very well.
Yeah, the audio is very disturbed. We have a lot of feedback and I don't know.
see, I
Maybe
have
you-
another PC open. Let me see if this is. I closed the PC. Just a minute.
Yes.
Okay, I down the volume. Okay, probably it's better now.
Yes.
Okay, so work investigates whether rooftop photovoltaic systems can satisfy local energy demand while reducing land consumption and preserving coastal land. Yeah, probably it's have any uh, so I don't have now. Just my
Uh, Yeah, we can. Now we can't see your presentation. Sorry, maybe try. Can you try to reactivate the sharing mode?
Okay.
Sorry, I apologize for these technical issues.
Uh-huh. Tell me when I can.
No, we can't still see it. Okay, now we can see the presentation.
Okay.
Okay.
But I still hear.
Okay.
So just I don't know if better.
Yeah, yes, we can see the presentation. We can hear you. The audio is a bit disturbed, but don't worry, we can understand. Okay.
Transition requires a rapid increase in renewable energy production. However, photovoltaic deployment through ground-mounted plants located on agricultural or natural land. This creates a paradox. On one hand, we are reducing carbon emissions and moving toward climate neutrality. On the other hand, we may be increasing land consumption and transforming valuable landscapes. This issue is particularly important in rural areas where agriculture, cultural heritage, and landscape identity represent strategic resources. For this reason, we asked a simple question. Can existing buildings become an alternative energy infrastructure capable of producing cleaner energy without consuming additional land? The study area considered in this paper includes 3 neighboring municipalities in Basilicata region, in southern Italy, Tito Satriano di Lucania and Sant'Angelo Le Fratte. These municipalities were analyzed as a single case study because they share similar geomorphological, climatic, and settlement characteristics. The area includes historic centers, industrial zones, and agricultural landscapes, making it representative of many rural territories in inland Italy. Therefore, the methodology can potentially be transferred to many similar contexts. On the right, you can observe the spatial distribution of soil consumption. In the upper part, we considered only buildings, while in the bottom image on the left, you can observe also the added distribution of photovoltaics panel and how this distribution worsens and how it increases. Before developing future scenarios, we analyzed the current distribution of photovoltaic installation. The results that you can see both in the figure and in the tables show very different situations among the 3 municipalities. In Sant'Angelo Le Fratte, photovoltaic systems are mainly installed on existing buildings. In contrast, Satriano di Lucania is characterized by a strong prevalence of ground-mounted installations. Tito shows an intermediate situation with a large amount of photovoltaic surfaces located both on industrial buildings and on agricultural land. These results suggest that land consumption associated with photovoltaic deployment is already a relevant issue within the study area. To address this problem, we developed an integrated workflow based on GIS, remote sensing, and spatial analysis. We combined digital surface models, building footprints, landscape constraints, Sentinel-2 cloud information, and population data. The workflow consisted of 5 main steps that I will show you in the following slides. It includes solar radiation modeling, cloud correction, rooftop suitability assessment, energy production estimation, and energy demand estimation. Finally, production and demand were compared through an energy balance analysis. The first step consisted in the calculation of seasonal solar radiation. We used the ArcGIS solar radiation model and a high-resolution digital surface model. This approach considers topography, slope, aspect, and terrain shading. As expected, south-facing slopes receives higher solar radiation, while valley bottoms and north-facing slopes receive lower values. The obtained maps represent the spatial distribution of potential solar energy across the study area. The second step is related to cloud correction. Solar radiation models generally assume clear sky conditions. However, real atmospheric conditions are influenced by cloud cover. For this reason, we developed a Google Earth Engine workflow based on Sentinel-2 scene classification data, and cloud occurrence was estimated on a daily basis and then aggregated seasonally. The resulting cloud correction factors were used to obtain a more realistic estimate of available solar radiation. This step improves the reliability of the final energy calculations. Once solar radiation was calculated, suitable rooftop surfaces were identified. In the slide, you can see the several criteria that were applied. To resume, protected heritage buildings in historic centers were excluded because they are protected because cultural heritage. Minimum roof dimensions and maximum slope thresholds were introduced. Roof slope and orientation was also considered in order to maximize photovoltaic efficiency. I did not write it here, but through this process, we identified more than 1 million square meters of suitable rooftop surfaces available of photovoltaic installation. The next step consisted of estimating photovoltaic energy production. And for each suitable building, solar radiation values were extracted through zonal statistics. Energy production was then corrected using standard photovoltaic parameters, including module efficiency and performance ratio. Conservative assumptions were adopted to avoid overestimating the final energy potential. Therefore, the results should be considered a minimum estimate rather than an optimistic scenario. This slide presents the key results of the study. The annual photovoltaic production potentially available on rooftops is approximately 153 million kilowatt hours. The estimated annual electricity demand of the study area is approximately 53 million kilowatt hours. In other words, rooftop photovoltaic systems could generate almost 3 times the current local electricity demand. This result demonstrates that significant renewable energy production can be achieved without relying on additional ground-mounted installation. From a planning perspective, buildings can therefore be considered a strategic energy resource. To conclude, 3 main messages emerge from this research. First, buildings should no longer be considered passive elements of the territory, but potential energy infrastructures. Second, renewable energy production and landscape protection are not necessarily conflicting objectives. Finally, GIS and remote sensing provide powerful tools for supporting evidence-based photovoltaic planning. The proposed methodology can support decision makers in identifying energy scenarios that contribute to decarbonization while minimizing land consumption. And that's all. Thank you for attention. I will be happy to answer any questions.
Thank you, Maria. Questions online or in room? Okay, have you considered also the possibility to locate solar panels in disused quarry, for instance, or other part of abandoned part of the soil, just for extended of the production of electricity by solar.
So in this many between these, for example, in the balance, energy balance, we did not consider the production cost of the photovoltaic panels. So a good idea to improve further the quote of energy photovoltaic panels would be to put them in the areas that you nominated. There is just a little problem that today, even we have many data and many remote sensing data, and also great machine learning methods. I hope that everybody is agree with this point. We are not able to have the ability to produce a really detailed land soil use and cover information. So to have these, it would be necessary before to have a very high level of details about this information. Then we can do what you asked me.
Okay. Someone else want to ask something? Okay. Thank you, Maria. We have now, I saw Anastasia Statiga, but also Angeliki Papadopoulou probably will be presented by you.
Yes, well, good morning, everyone.
Okay, Angeliki Papadopoulou, Apostolos Lagarias, and Anastasia Stratigea, Machine Learning Methods for Fire Risk Assessment in Wildland-Urban Interface, a case study Attica region in Greece. You can start.
Thank you very much.
Well.
So, can you please tell me if you see my presentation in full screen?
Very well.
Thank you. So, good morning, everyone, again. My name is Angeliki Papadopoulou, and I'm a PhD candidate at the National Technical University of Athens. Today, I'm going to present you our work, which is titled Machine Learning Methods for Fire Risk Assessment in Wildland-Urban Interfaces, a case study in Attica region in Greece. This is a joint work with my supervisor, Professor Anastasia Stratigea, and my committee member, Apostolos Lagarias. So, starting, I would like to outline the structure of our research. Our main concern is the rising severity and frequency of forest fire events that indicate the urgent need for integration proactive strategies into disaster management plans. A fact that highlights the importance of wildfire risk assessment in urban and peri-urban areas. So, building on that concern, our goal is to develop a methodological framework for assessment of wildfire risk in forest areas located in close proximity to urban one, especially in the ones said wild and urban interfaces. Methodologically, first we select to implement a number of machine learning methods in support of that goal in WUIs, resulting to mapping the fire risk assessment in WUIs and result to a comparative analysis of the ML method's performance, metrics, and outcomes. Our general area of reference is the Mediterranean region, which is called as a hotspot in climate change terms, is an area with high vulnerability and exposure to climate hazards. According to many reports, especially ICCSA, Mediterranean region has many specific characteristics like extensive heat waves, droughts, the rise of the sea level, intense urbanization and urban sprawl, particularly in the seaside area, extended change of land use and activities, and also high incidence of wildfires due to human negligence or intention. All those characteristics result to the increasing wildfire risk, the number of incidents, and also the surface of the burned areas, and lead to severe consequences not only for natural ecosystem but also for human-built environment. That brings us to the core area of our study, which, as I said, are the wild and urban interfaces. As for their definition, they are the zones where the urban fabric comes into close contact with fire-prone vegetation areas. Some characteristics of those areas are the intense urbanization and the poorly planned urban sprawl, the abandonment of traditional activities in those areas like agriculture or livestock farming, and also the rising in touristic activities, especially in the seaside area. As a result, in WUIs across all Mediterranean coastal areas, we have increasing fire risk due to proximity with flammable wildland, the rising threat for not only for human life but also properties and urban infrastructure, and also the integrity of the natural ecosystems. We have seen remarkable losses in human, socioeconomic, and environmental terms. Also, studies show that there are challenges in firefighting efforts for wildfire control and suppression, and all that lead to the environmental degradation and alteration of the natural landscape. So, moving forward to our methodological framework, it consists of 3 stages. On stage 1, we have the insight of the study area, which is the Attica region, and the overview of the wildfire events and the burnt areas for the time period between 2000 and 2024. On stage 1, also we have the literature exploration for fire-related factors leading to an establishment of a fire risk-related pool of variables that we're going to use as an input for implementation. On stage 2, we have the data acquisition and the processing, and also a literature exploration for ML methods for fire risk assessment, the establishment of the selected methodologies that we are going to implement, and finally the description of the evaluation metrics. On stage 3, we have the overview of the final data set that we are going to use as input, and the implementation of the methods, which shows 6 individual learning methods and 1 integrated learning method, all of that leading to mapping fire risk assessment in WUIs, do a comparative analysis between their performance metrics, outcomes, and for methods in general, and at last we have a validation with historic burnt areas. On stage 1, we have our case study area, which, as I said, is Attica region. Attica region consists of 8 regional units and 66 municipalities. As for the topography of the area, as you can see on the map on the right, we have a prevalence of mountain complexes, especially mountains Pykilo, Egalo, Parnitho, Pedeli, and Imitus are encircling the Attica basin, which is the main urban space of the region. The population of the region is approximately 3.81 million inhabitants according census to 2021, and the area covers 3,808 square kilometers. The climate is characterized as maritime with dry, very warm and extensive summer, and some specific characteristics of the area is the extensive urban sprawl that we can see that goes towards mountain parts, and also the increased seasonal population and touristic activities that we can also see on the seaside area, especially in summertime, which coincides with the fire season in Greece. On the map, you can see the burnt areas for the period of time that we are studying between 2000 and 2024. So, Attica region is an area that has suffered recurrent wildfire events through that 24 years, and we should mention the tragic wildfire at Mati of 2018, leading to 104 casualties, and on Vernavas on 2024 with 1 casualty. So, after all those recurrent events, we have extensive repercussions on natural and socioeconomic environment, with wildlands, wild and urban interfaces are exposed to extensive fire risk during the fire season due to their proximity to flammable vegetation. On the chart, we used data from Hellenic Fire Service in order to do an overview of incidents and burned areas for the same time period between 2000 and 2024. We can see a declined trend on the number of the incidents. However, on the recent years, we can see that the extent of the burnt areas has risen, and that led us to the thought that despite the rising number of the events, their repercussions are extensive to the region. Moving forward on stage 2, we also have the exploration of factors and variables, which came from the rising importance of wildfire risk assessment in urban and peri-urban areas. The establishment of a pool of factors is very important as a tool of support of fire risk assessment in wild and urban interfaces, and in order to study their attributes. To this end, it is necessary to conduct an extensive literature review to similar studies in order to identify the contributing factors and study their interrelationships, facts that comes out of a good insight what we should do to the current state and particularities of the study area. Also, it is very important to assess linkages with historic events and burned areas. And at last, we have to ensure data availability, because also it is a very important aspect for the success of the procedure. So, to our work, we used a pool of 14 independent variables. As you can see, they are categorized into 4 general categories: topography, which includes elevation slope aspect; environment with tree cover density and NDVI; climate with temperature, wind speed, precipitation, and humidity; and urban space with distances from road network, settlements, rivers, popular distribution to the area, and land use. Moving to stage 2, we have the methodological part, the more technical part. As we saw on literature exploration, state-of-the-art methodologies such as machine learning are gaining great momentum to literature due to their predictive capabilities and promising results. So we select and implement 6 literature-driven individual machine learning methods, specifically random forest, XGBoost, LightGBM, logistic regression, support vector machine, and multi-layer perceptron, and 1 integrated ensemble method, specifically soft voting ensemble, which combines all the aforementioned 6. Then we use the burned areas from EFI's Copernicus program in order to establish the binary dependent variable and derive fire and no fire points, accompanied with the 14 independent variables that I mentioned to you before. We have the implementation of the machine learning methods. Then we have a comparative analysis of their predictive performance using 7 evaluation metrics and the outcomes. And then we have the final forest fire risk maps and validation of them with the use of burnt areas for the same time period between 2000 and 2024. We created the maps of the independent variables that, as I said, we used as input for implementation. On this slide, you can see the 14 maps for the 14 independent variables. And then on stage 3, after we have the full dataset for implementation, we proceed to the overview of the dataset, starting with descriptive statistics for all continuous variables. And we calculated mean value, standard deviation, max and mean value for all continuous independent variables, as you can see on the table on the left. And for categorical variable, independent variable land use, we calculated the distribution of the classes, as you can see on the table on the right. Then, in order to ensure that our dataset was statistically robust, we have a multicollinearity and correlation analysis. For multicollinearity, we calculated variance inflation factor, VIF, for all independent variables. As you can see on the table on the left, VIF values are all under 10, which is a recommended threshold in literature in order to avoid high collinearity redundancy. Then we have a correlation analysis, Spearman's rank correlation analysis for all the continuous independent variables. all of them stay inside the critical range in order to be able to proceed for the implementation. So we move forward with the implementation of the ML methods. Then we used 7 evaluation metrics, as you can see, in order to evaluate the predictive capability, the robustness, and the performance of the methods. We used accuracy, precision, recall, F1 score, Matthews correlation coefficient, and AUC-ROC, and also a spatial 10-key fold cross-validation. As you can see on the ROC chart on the left and the table on the right, all methodologies, all methods show high predictive capability and robustness, with the metrics being very successful. Finally, we have the forest fire risk assessment maps for all 7 methods that we tested, and the burnt areas between 2000 and 2024 for validation. The maps show the forest fire risk probability values for all methods, which range between 0 and 1, from low to very high risk. We can see with brown color on all maps the highest risk values, which are areas covered by forest and permanent vegetation, whereas with blue color we can see specifically the urban areas. All maps appear to have a high degree of consistency regarding the spatial pattern of the fire risk, but we can observe that some methods like XGBoost, Light GBM, logistic regression, and support vector machine appear to demonstrate a more well-rounded, more defined boundaries around the very high risk areas, whereas random forest and multi-layer perceptron appear to demonstrate a more gradual fire risk demonstration, distribution, from the urban to the forested places, which indicates the rising vulnerability from urban space to those forested areas, which is a main characteristic of the WUIs. As we can see, for the validation with the burned areas, we have a strong alignment to all the methods that we tested. A little to understand better the differentiation and the spatial pattern, here on the zoom to 2 examples of the methods, random forest and XGBoost, you can see better the minor differentiation in the spatial pattern of fire risk probability that I mentioned to you before. And also what we must say is that all ML methods appear to identify successfully some areas within the urban, the Attica Basin, some vegetated low hills with high risk areas, which shows us that the models have high geographical sensitivity, and is a fact that correlates also with the strategies that here in Greece we apply on days with very high fire risk, as those low vegetated hills are close to the public on those days. So concluding this presentation, we have the conclusions. Our work shows us that all models have high model consistency and alignment. As I said, all the patterns show high geographical consistency among them, and we have a strong alignment with historical and burned areas, which provides us a robust qualitative validation. From the metrics, we show that the tree-based methods like XGBoost, Light GBM, and random forest appear to be a little bit as front runners because they prove to have high efficiency in capturing the complex and non-linear patterns of fire occurrences. Also, the minor divergence between test AUC and spatial cross-validation AUC shows us that we have very high spatial generalization, which highlights a strong stability and resistance to spatial overfitting. We have an effective capture of WUI areas, especially from models like random forest and multi-layer perceptron, which captured the gradual transition from urban, the gradual transition of fire risk from urban to forest areas, which is a very important characteristic of WUIs. And then we saw that the voting ensemble can serve as an excellent balanced approach because it combines all 6 individual models and can effectively smooth some variances or weaknesses that may have without compromising the result. Concluding, as for the future development, we can propose a transition from static mapping to early active early warning system, and that we can succeed that with the integration of time variant data along with the static variables that we use, and can provide more up-to-date outcomes with the use of real-time data. Also, testing to test the geographical transferability of the methodology can highlight specific strengths or limitation, aiming to make the framework more universal and transferable to the approach of wildfire risk modeling. And at last, always a data enrichment could be a good improvement of the methodology, because using larger and quality dataset can enhance models' generalization capabilities, prevent spatial overfitting, and lead to more robust outcomes. Thank you very much for your attention.
Questions?
Can I pose a question?
Thank you,
Yes,
Liliana.
I would really like to, first to thanks, for these first three presentations. They have been all very relevant, taking into account, what is now going on in the European region, in Europe at least. So, just to ask, the colleagues from the Greece, did they manage, all this information, because now it's a huge accent on the disaster risk prevention, to somehow to include and to inform the relevant authority in the Greece and Attica region, on this information, how to prevent, the fires, in this area, peripheral areas, or, do you plan to do somehow that, or?
Yes, thank you very much. This is our main goal. As our strategists here in Greece, we saw from our research that they lack with tools in order to have a successful fire risk probability maps, in order to be able to have a better planning for strategies, and to work a little bit more in the proactive road. So yes, this is the first step, in order to check the tools, see how they work, how they perform. Yes, and this is our goal, in order to have something, create something that could be feedback to proactive strategies and help the mechanism and the disaster planning in our country, in Attica region.
Yes, I look forward maybe next year, to hear in the conference how you manage that, because we also have this issue here. We have a disaster risk register, but still, there are no good plans, especially on the local level, where the risk is the highest, for the humans and for the economy. So I would like to hear how you manage, maybe this could be the good, model also for Serbia, how to develop these plans and to finally start putting data into the action. So yes.
Yes. Thank you very much. Yes. We'd be very happy if we succeed to do something like that. This is our goal. As you saw on the maps, the level of resolution can help to go down on a very local level. We can have information on local level and help the people and have more specified and more local planning. Maybe
yes.
on a municipality level, even, we can try to have.
Yes, actually, this could be the link also to the previous, the paper, the presentation, because this, since I don't know, last 10 or 15 years, in the Europe is discussion, how we don't have enough detailed data, and we are still talking about that, now there is a huge, intent, to use already available Sentinel, the images, everything, from the Copernicus program. But still, somehow we don't reap, the benefits, of all this information there. Now, for example, now in Serbia, we have some other issues like illegal buildings, so we try with the drones in the area where you have the residential, area where there is a building land, the density of the buildings is high. We are using the drones in order to reap and to find those very detailed information that are actually useful for the decision making. I mean, all this data that are very, how to say, general, you could see it's more informative, but somehow we are talking about this, that we need more detailed information for everything, but still this data, there are not this data. And, then practically planning that would be really beneficial, for the society is missing still. So I don't know if you agree with me, if someone could say a little bit more of the participants about that. But, I think that we are still missing those information.
Yes, yes. Sometimes the data availability is the main problem, to run that kind of methodology, especially machine learning, which, as we know, needs a huge amount of data in order to provide a robust performance result. And however, we have some data from Copernicus, which are very good, as I can say, because I specifically and mainly use data from Copernicus. We still lack information on a local level. Here in Greece specifically, we lack information on a local level, maybe on the census block, maybe for the roads, in order to plan evacuation, maybe. Yes, the data on the local level are still not very, very good.
Yes, and then there is a risk, I don't want to, spread this discussion maybe too broad, but, then there is a possibility you could put the sensors, you could put the, there is this is why we have this big data discussions, but then I'm on the end, I'm how to say, even if we have those information, because detailed information, it's a huge amount of information, do we know to deal with them? Of course, the machine learning could help us, to deal with this information, but I'm somehow on the end, I'm wondering, even if we have all this information, would we be able to produce meaningful decisions and meaningful actions? I'm not so sure and convinced, to be honest.
Yes, I agree with you. Yes, yes.
That's good. Yeah.
Yes.
Thank you very much for your remarks and the conversation. Thank you.
Thank you.
Jerry, just two suggestions. After this session, I will send to Anastasia two papers. We don't have time to discuss now, but just two papers. One that I developed with Maria Danese 15 years ago, probably, when in class or probably in forest fire, in analyzing data with satellite images and using the spatial autocorrelation analysis, and the data will be more clean and probably could be useful for you. And the other paper that I developed more or less 10 years ago with Federico Amato was about the analysis of forest fire on the urban-rural interface in Portugal. It was in a project, a European project. And also we used obviously fuzzy logic and calibrating the model with multi-layer perceptron and Markov chain. Probably published on environmental modeling and software, probably would be useful. After the session, I'll send this paper to Anastasia. Probably could be useful for developing your research. Obviously, if you have any question, you can write to me when you want. No problem at all. Okay, thank you again.
Thank you.
Thank you.
Okay, we can start with the next speaker. It's a very pleasure for me to introduce Liliana Zitkovic, small parcel system, a geospatial platform for enhancing cross-fertilization between spatial planning and territorial cohesion policies in Serbia.
Yes, thank you. It's a very long title, but I would immediately stress. I hope you see the slide.
Yes.
Yes.
Okay.
You will win the prize for the longest title in the conference, probably.
Oh, okay. Anyway, any title is good, So I mean, what can I say, you know, but the main point is that, you know, the digitalization of spatial planning, it matters, and it really could bring, you know, the more benefits than we would expect, you know, and just besides, you know, the having the nicely done, you know, environment where we work and live. So my paper and my research, you know, it's a more professional one comparing to the previous presentations that are more academic research. This one is related, you know, to what I'm working in for the government in Serbia, and I'm motivated, you know, by the recent, you know, articles. I would say the growing number of articles about cohesion policy implementation in the previous programming period, 2021-2027. There are, of course, some good points, but there are some lacks, you know, in this implementation. And I would concentrate more on that and say what we could do, you know, or at least what we are doing in Serbia to overcome those issues. So, as I said, you know, there are some, you know, good and weak points, you know, in the implementation of the cohesion policy in the previous programming period. And the EU is preparing for the next programming period, 2027-2034. And in this analysis, they made a conclusion, not just that, of course, the cohesion policy should be changed, you know, but the implementation should concentrate on the member states' spatial planning policies and systems, particularly on the national level, that, you know, it were more prone to integrate with the cohesion policy delivery mechanism and the investment tools. So the aim of my paper and this presentation is to present you the smart parcel geospatial platform that could be the good solution, you know, for the cross-referencing and between the cross-fertilization between the spatial planning and the other territorial cohesion policy in Serbia. And one day when Serbia joined the EU, hopefully to be the support for the cross-fertilization with the cohesion policy. So,
Liliana,
yes.
are you moving the slides or not?
I move. Yes, I move it now. You don't see?
No, we are able to see just the first slide.
Okay, then let me start.
Try to move the second.
Or maybe when you share, select the entire screen, not the window.
Okay, now I have the entire screen.
Okay.
What do you see now? No, you see. Okay, maybe.
Okay.
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 No.
Yes. Now, yes. Okay. Now we can see.
Do you see now introduction slide or what?
Introduction.
Okay, I moved already on the 4th.
Okay.
Yeah, I apologize. So everybody knew. I mean, everybody know about the cohesion policy. You know, there is a main the big fund that have a main aim to reduce development disparities in the European across the European regions. But you know, as already mentioned, there are mixed results. And of course, there is a conclusion that for the next programming period, there is a need for the changes in sense of as I said, the cohesion policy itself, but also to this so-called shared management model between the EU and the member states, in sense, you know, that it should be more top-down approach and not to be like before bottom-up or middle-up approach. So this more top-down approach should relate to the integration of the cohesion policy investment tools and their coordination with the national territorial instruments and the budgets. So, as I already mentioned, you know, they noticed, you know, that besides these changes, they noticed also in the previous period, you know, that the integration between the cohesion policy delivery mechanism and spatial planning system was very active because, you know, these policies and systems show more flexibility and suitability to integrate with the cohesion policy instruments comparing to the other sector policies. And this was particularly noticed in strategic level, that means on the national or the federal level, depending on the member states, comparing to the local local planning institutions that are more oriented toward the regulation and the implementation of the legal framework. So noticing that, the ESPON experts have been delivering, the policy brief that proposed 7 steps how to improve even that cross-fertilization between the spatial planning and cohesion policy at the national level in the coming programming period. Said that, I have to mention, of course, that in the moment since the 2011, member states are working a lot on the digitalization of spatial planning system, and the main results include centralized planning registers and national platforms in general. Of course, there were some other results, they're digitizing the processes and other, they are building other, the platforms, but these 2 results are usually the main and the most common digitalization goals and outcomes. So this means, that at the moment, since they identify that the cohesion policy is communicating very well with the spatial planning system and practices, this digitized spatial planning practices and digitalization of spatial planning show this potential, for cross-fertilization between the cohesion policy and other sectoral policies and the spatial planning and the national level, particularly in those 7 steps, where I would like to, somehow focus on one step that the name in this policy brief, if you look, it's called the champion or support joint working. And this relates directly, particularly on the national platforms that are delivered and that are working in the member states. Digitalization of spatial planning practice in Serbia is, to be honest, on the very low level. There are a lot of problems, but despite that, the spatial planning practice is at the moment unchanged, and we are suffering from the inefficient land use and limited investment capacities, particularly in the local level, where the local spatial and urban planning offices, they don't have enough people, they don't have enough, technology. There is no such a big coordination vertically or horizontally with other spatial planning documents, but also with the other sectoral plans, that are very important to move and to allow investments to come to the local level and to make people to be able to work and live, for the life. In order to change that, Serbian government adopted the Sustainable Urban Development Strategy, but still, there are not some concrete action translated and implemented, on the local level. So practically, everything is standing in the moment, more or less, let's say. In that situation, Republic Geodetic Authority, together with the long-term partner Lantmäteriet and supported by the Swedish SIDA, this is an international agency for the international cooperation, within the project E-Plan for E-Space Smart SDI, developed, the geospatial platform. This platform is the first step in the digitalization of the spatial and urban planning practice in Serbia, and it's developed within the Serbian NSDI, meaning that already has this inherited, data integration capability that could position this geospatial platform as a main support for the cross-fertilization between the spatial planning and other sectoral policies, and in future to enable, the integration with this cohesion policy, delivery mechanism, and the investment tools. This platform is based on the recommendations and the best practices globally and on the EU level, and also in sense of the data, standards, and technology, but also it takes into account, the national needs. From the global I would like to mention that and also within it developed the UN GGIM, the expert body that adopted, UN IGIF recommendations that are there to improve the NSDI in every member state, And also there is a implementation of the FELA. FELA is the implementation of UN IGIF in the domain of the land management, and the Republic Geodetic Authority is the main body in Serbia that is dealing with the land management, and we try to do it in efficient and effective way. On the EU level, I'd like to mention Inspire Directive that is at the moment, as you probably know, in so-called simplification mode. There is this Green Data for All initiative that you should simplify and make administrative burden less for all member states in the domain of the environment data management and the production. Of course, there is we follow the recommendations from the European Data Strategy and the Implementation Act on the high-value data sets that I think that most of you probably heard about, And when I talk about the national needs, I talk about, the needs that are already developed and accommodated within the NSDI, Serbian NSDI. We call it the Geo-Serbian. So the Smart Parcel platform itself, it's unfortunately at the moment it's only accessible from Serbia. So due to the hackers attack we had a couple of years ago, but hopefully one day if you come to Serbia, you could really very directly and openly, open this platform and look at the data that I'm going to show you during this presentation. At the moment, we developed this platform catalog of planning documents, catalog of entities accredited for the land use conditions issuing. We have a catalog of legal acts, knowledge base that practically have information how to manage, and what you could find within this geospatial platform. And of course, for the first time, we have a database of planned land use in the Inspire compliant way, and that I'm going to say about a little bit more in the next slides. Catalog of planning documents is actually the centralized register of all spatial urban plans for the territory of Serbia. Once, when you, for example, want to build something on the parcel you have, I assume that you have a parcel, for example, in the building land, then you could practically have a list of all planning documents, all spatial urban plans that are valid for the cadastral parcel that you search, identify, and that is yours. You could find information, what is the name, when this plan was adopted, who adopted it, and whom you should address, for more information about it. And also it could, there is a link and you could read the text, if you want, and you could have a look at the maps, that are integral part of the spatial and urban plans. On the same parcel, by identifying and making active, this information from the catalog of entities accredited for land use conditions, you could also see to whom you should address, in case you need electricity, the access to the road, and also you could check if the parcel you have, and you want to build is in the zone of some natural cultural heritage, so there are some protections, so you could only, for example, make some activities, and on that parcel, on that space, and this type of you could, for example, within this catalog, you could see information how to contact these institutions, and to ask about the details, and how, and this is kind of a shortcut, to the issuing of the building permit in Serbia, because today it takes a lot of time, a lot of papers, but at least here, this at the beginning, this platform is something that you could collect information in case you want to build something. So the catalog of legal of all acts related to the land development and management, and this catalog is practically only supportive to the previous two catalogs I described. So when I said for the first time we have the planned land use information, that doesn't mean that the planning documents in Serbia are created, on the paper. They are created digitally, but without any standards, at least for the moment. So as a pilot, we used the 18, we asked the 18 local self-governments, they volunteered, and we translated the information from the local self-government spatial plan into the vector format in the database that is completely Inspire compliant. we have only 6 basic land uses. So as you could see, on the right side, this information could be used only informative, and for any other information about each parcel and the potential of that parcel to be developed, you need to consult, the spatial plans and to consult the other catalog of the institutions that are dealing with the land use regimes. So all these catalogs that we in database we developed, we integrated with the information that are already available within the Serbian NSDI. These are the information from disaster risk register, the information from the natural and cultural heritage protection agencies, and it proved, its ability that that this platform is the geospatial platform Smart Parcel could support integration between the spatial planning data and the data of the other, sectoral policies, and it could support let's say it supports some information and the informative decision making and the policy management at the moment. Of course, we would work much more on this platform, but at the moment, this is a starting point to develop the central, reliable, and permanent collaborative environment in line with those 7 steps, as I mentioned already, for improvement of the cross-fertilization between the spatial planning and the sectoral policies and the cohesion policies itself. As a conclusion, I would just like to say that, just to confirm, it's with this parcel is a significant step towards, at least in Serbia, to have more transparent, efficient, and legally secure land management. This is a proof that digitalization of the spatial planning system and practice has a substantial influence not just on the planning and the quality of planning data and development decisions, but also it contributes to better implementation of the cohesion, the other cohesion policies on the EU and level, but also other sectoral policies, and to make the whole development and territorial disparities to vanish and disappear, but more coordinated approach to the development of the space. So the further development of this platform would focus, of course, on addressing these gaps that is noticed between the planning practice on the national and local level in Serbia, and of course resolving territorial development disparities. There are of course discrepancies. Not all regions are evenly developed. And also we would promote, and further develop this platform to be able to allow the great participation of non-expert users, not just the spatial and urban planning stakeholders in Serbia, but also the citizen investors, to be more involved into the development. On the end, I would like to thank you, and I'm open to any question if there is from the audience.
Okay, now I'm reading your last slide. The football is a distinct thing. You have a balance between activity.
It's in line with the championship, and I saw this. This was a call for in the Norge Digital. There is an invitation to join some workshop, and I saw this, and I thought that is very good. It's brilliant.
Okay. Thank you, Liliana.
Thank you.
Very interesting presentation. Questions? Okay, I really appreciated your presentation for several things, very complete experience, and the good news is that after more or less 20 years, INSPIRE directive has been considered in developing digitalization roadmap and putting the map online. Probably is good news, because I saw other experience, not the best experience in Europe, but not much, because in a great part they use just shape file in a computer. And in this case, I saw the metadata or the kind of INSPIRE requirement implemented in this experience. I really appreciate it, and very complete, but this is completely realized in all Serbia country, or just for a pilot area?
It should be whole, this is only the pilots, we expect, actually, we were thinking to go forward, to do more, in sense of the standardization for the area that are more, how to say, more detailed for the cities, for example, general urban plans, general regulation plans, but to be honest, completely honest, we need, the spatial urban planners on our side, somehow. It's how to say, it's not on the Republic Geodetic Authority that is dealing with the cadastry and the land management to maybe do digitalization of spatial planning. Our intention is to support them because there is no response, that there is a digitalization in other domains, but this domain is lagging, at least in Serbia. So our intention was to somehow, inspire them to make this first step. Because for the real estate cadastre that has valid and reliable information, we need information from the spatial and urban plans. And this is our idea to make a first step. We managed to have this project in London. And then we expect them, to join us now in next steps, because it's really important for the standards that are even, how to say, more detailed. And that is going to influence how spatial and urban plans are preparing. We need them on our side, and we need them, to how to say, to accept that and to take the ownership of the project. And I think this is going to happen soon, because there is a great need for this type of step and for the digital information, because it's obvious, how to say. The more you have digital information, the more you are aware that there were some steps and some decisions were wrong. So we are practically on there, and I think that I would like to be, as always, optimistic and say that the next step we are going to make together with them, and and particularly because in the law it says that 2028 they should start preparing the plans only digital in using the ArcGIS, software, ArcGIS technology. No, okay. Apologize, GIS technology. Yeah, apologize for that. And okay. About Inspire, Benjamin, I wouldn't like to make so many comments, because maybe you also know that there is in this simplification, there are a lot of discussion in the EU. They propose a lot of things to be cut from the Inspire directive. Then there is a issue, should this directive, survive, except those standards that we are all using and that are valuable, of course, but this is the separate discussion from this conference.
Okay, thank you, Liliana.
Thank you.
We can move to the next speaker. Krivileka, Angeliki Papazoglou, and Anastasia Stratigea. The paper is identify insular tourism hotspot at fire and flood risk, case study of Rhodes Island in Greece. Who is the speaker? Anastasia? No.
No, me, Angeliki. Again.
Again.
So.
You can start.
Okay. Is my screen okay?
Okay. Yes. Okay.
Oh, just a minute. Okay. So, good morning again. I'm Angeliki from National Technical University of Athens. This presentation of our work is titled Identifying Insular Tourism Hotspots at Fire and or Flood Risk. Case study Rhodes Island, Greece. This is a joint work with my supervisor and Dr. Leka. So, as we know, tourist pressure is a defining feature on the Mediterranean region, not only in general, but especially for insular territories like Greek islands, Paros and Santorini, Majorca in Spain, Sardinia and Cyprus. all those insular territories share common patterns regarding tourism pressure, which have some major factors like coastal concentration, seasonal population growth, and extensive land use pressure to that limited vulnerable territories. However, along with tourism pressure, there is also the climate risk, change risks in the Mediterranean region. As we know from reports, especially IPCC, Mediterranean region is characterized as a hotspot in terms of climate change and appears to have high vulnerability and exposure to climate hazards. However, there are main 5 categories that are typically highlighted for our region, which are the warmer summers, the stress that we have in water resources, the loss of biodiversity, also the loss of marine biodiversity, and the rising risk of diseases. All those factors raising the vulnerability of our region and the exposure as well to the climate hazards. So the combination of tourism pressure and the climate risk in those limited and vulnerable insular Mediterranean territories creates a future for that island destination that is increasingly demarcated by the combined pressure not only of mass tourism, but the coastal urbanization and the climate change. As we know, in Mediterranean region, tourism is an important pillar of development, not only in the general meaning, but also for local development. And the mass tourism on that insular territories is the main source of pressure, not only on natural, but also on cultural resources, generating energy stress, water stress, traffic congestion, urban sprawl, and also land use conflicts. So the intense tourism activity in islands combined with coastal population pressure leads to dense development, especially along to the already vulnerable and exposed coastal zones, with built-up coastal areas also be increasingly exposed to climate change impact, especially as we saw in the recent years, wildfire and flood-related events. So Mediterranean regions, with all this, sometimes that pressure overlap with environmentally sensitive areas, settlements, tourism infrastructure, and wild and urban interfaces, which are the areas that are close in proximity to flammable vegetation. So, to this work, our goal was to identify tourism hotspots in our case study area, which is the Rhodes Island, that are exposed to fire and or flood risk. And all of that in order to support proactive planning and policy response for a more climate resilient and sustainable development. The reason that we are concerned for that was that climate change and anthropogenic pressure increase wildfire and flood risk in Mediterranean island tourism destination, as I said, and we chose to do that using tourism pressure indicators, GIS spatial analysis, the use of random forest algorithm in order to assess fire risk in that island, and the officially delineated flood-prone zones. So, moving to our methodological framework, we used 3 defining terms, we can say, which are climate change risks, climate resilient tourism development, and insular territories. All those terms are interlinked, and our methodological framework consists of 5 steps, as you can see on the diagram on the right, that I'm going to explain to you on the next slide. So, for step 1, we have the indulgement into the study area. We study our Rhodes Island, which is our study area, in order to grasp the main spatial, environmental, socioeconomic, and tourism attributes of that island. On the step number 2, we have the identification of tourism hotspots. In order to do that, we use density and intensity indicators in order to assess tourism pressure on the island, and then we mapped the hotel and Airbnb infrastructure patterns on the island. On step 3, we have the flood and fire risk. for flood risk, we identify the flood-prone zones with the use of the officially delineated flood zones from the water district of South Aegean. And as for fire risk, we identify the fire risk zones of the island by exploring fire risk related factors in order to create a pool of spatial variables as input to the tool that we're going to use. And we use the forest-based classification tool, which runs random forest algorithm, as I said, in a GIS interface. On step 4, we used the resulted fire risk map combined with the historical burnt areas between 2000 and 2024, the Natura 2000 areas of the island, the flood zone, the official delineated flood zones, settlements and population distribution from census 2021, and Airbnb and hotel accommodation, in order to identify that hotspots that combine all of that risk. And as for step 5, our goal of all that methodology is to support proactive planning and climate resilient tourism policy. So starting from our case study area, which is the Rhode Island, as you can see on the maps on the right, according for topography of the island, we have a average mountain that dominates its landscape, and it's followed by lower hills along the extent of the island. On the map, you can see the extension of Natura 2000 protected areas that they are on the island. As for the population, according to Census 2021, it is approximately 1,025 inhabitants, and the cover area of the island is around 1,401 square kilometers. Some characteristic of the island is the extensive urban sprawl, especially towards the coastal area of that, which results to expanding WUIs towards the mountains part. And also, we can see the increased seasonal population and touristic activities, especially during summertime, as Rhode Island is a very popular touristic destination. As for the tourism pressure on Rhode Island, we chose to use 4 tourism pressure indicators, 2 for intensity and 2 for density. As you can see on the table, indicators 1 and 2, we chose to examine not only Rhode Island, but also the Dodecanese Island complex, which Rhodes is a part of that, and also a larger, can I say, spatial scale, which is the region of Southern Aegean, in order to be able to make some comparisons and show the place of Rhode Island on that place. On indicators 1 and 2, you can see that the values of Rhode Island are closely similar with the values of the other 2 scales. However, we can see that on indicator 3, tourism accommodation density, the value of Rhode Island is higher from the other 2, the Dodecanese complex and the region of Southern Aegean. And also on indicator 4, we can see that also Rhode Island value is a little bit higher from the Dodecanese complex, but lower from the region of Southern Aegean. All of that tell us that Rhodes faces moderate tourism intensity, but much higher tourism density, which results in a severe spatial pressure due to the high concentration of hotel and Airbnb accommodation on the island. This fact creates a localized stress, especially on the seaside area, on land use, infrastructure, the natural resources of the island and the coastal ecosystems. So we try to combine, to identify, first of all, the spatial patterns of tourism activity and combine them with the wildfire risk in Rhode Island. On the left, you can see the 2 maps with the spatial pattern of the hotel accommodation and Airbnb accommodation. And on the right, you can see the chart that we used data from Hellenic Fire Service for wildfire events and burnt areas for the period of time between 2000 and 2024. What we should mention here is that we can see that on 2023, the pink bar that is very high, which is the wildfire of 2023, leading to an emergency evacuation on the island. And on 2024, it was followed by a very large flood in the historic term of the island. So from that, we can see that tourism hotspots are located mostly in the coastal areas and are intersected with high fire risk areas. Moving forward to the methodological part of our study, from literature exploration, we saw that the state-of-the-art methodologies such as learning are gaining great momentum, generating capabilities and promising results. So we select a methodology based on the moderate level of user friendliness and specialization for its implementation. So our framework consists, first of all, with the establishment of the binary dependent variable that we used burnt areas from EFIS data of the Copernicus Emergency Management Service program in order to derive fire and no fire points, and also the selection of 15 independent variables that they were used as input to the tool that we chose. So then we have the implementation of the forest-based classification tool, which runs the random forest algorithm in a GIS interface, which has automated procedures for deriving assessment outcomes. Then, derived from the tool, we have the predicted performance and the outcomes. And at last, all of that, the final forest fire risk map was combined and validated with the use of burnt areas, Natura 2000 areas, flood zones, settlements and population distribution, and Airbnb and hotel accommodation. One of the main parts of our research is the establishment of a very well-rounded data set of factors and variables in support of the rising need for wildfire risk assessment. So in order to do that, we done an in-depth analysis of the current state area and its particularities in order to identify the contributing factors and the interrelationships. And we chose 15 independent variables, which are categorized on the 4 factors that you can see here: topography, climate, environment, and urban space. Also, we searched the linkages with past events in the island and the data availability in order to be able to have the most successful outcomes. Then we created the maps of the 15 independent variables that we used as input to the tool, and we implement the tool in a GIS interface. From the tool, we have derived the importance values of the independent variables according to the forest-based classification tool, as you can see on the table, with humidity having the highest importance value and dominant leaf type having the lowest. Then we have the final forest fire risk map combined with all the aforementioned data that I mentioned to you. We have the forest fire risk values ranging from 0 to 0.85, from low risk to very high risk. As you can see on the maps, with brown color, we have the very high fire risk areas, which are mainly observed on the central part, especially the mountains part of the Rhodes Island. Also, very high values we have on the northern, eastern, and western coastal zones. With colors, with yellow color and green color, we have the high and moderate risk areas, which are surrounding the very high risk zones and appear to be relatively extended on the central part of the island. The low risk with blue color can be identified mostly on the north and the south part of the island. Also, as you can see on the top row on the left, we have the map accompanied with burnt areas from 2000 and 2024. We can see strong alignment with burnt areas for that period of time. And also on the right, we can see the same map accompanied with the flood zones, which appear to align with specifically moderate and to very high fire risk areas. Also, on the bottom row, you can see the spatial pattern of Airbnb accommodation and hotel accommodation, and we can see that tourism hotspots which are especially on the northern part of island, are located between that intersection of high fire risk and flood risk. So concluding this our presentation, we have the conclusion, and we saw that climate change risks are highly important for Mediterranean coastal and insular tourism areas, and this study tries and aims to be a replicable methodological framework for identification of tourism hotspots which are exposed nowadays to fire and flood risk. As for the predicted performance of the tool, we show that we have a strong overall predicted performance, which indicates that the proposed tool is capable of identifying fire-prone and non-fire-prone areas and capturing the complex pattern and non-linear relationship for fire occurrence. As I mentioned, Natura 2000 protected areas align with high fire risk zones ranging from low to very high, which is a fact that underscores the imperative need for steady monitoring in order for conservation purposes of those protected areas. Also, tourism hotspots such as City of Rhodes, Lidos, Afandu, Faliraki, and Ialissos are, as I said, located mostly on the northeastern and northwestern coastal areas of the island, where the flood risk overlaps with moderate to high fire risk. So these areas face a combined risk with fire and flood, and further, they are intensified by climate change, the poorly planned urban sprawl, and the expansion of tourism infrastructures. So, as for future tourism development on the island, in those specific vulnerable coastal zones, we suggest that it should be limited, redirected, and being subjected to stricter resilience standards. So, from our literature exploration to strategies and plans, we show that fire and flood risks are not sufficiently integrated into spatial planning, regional policy, and disaster management. So, the results of our work can highlight the need for proactive, place-based, and risk-sensitive planning and related policies. Thank you very much for your attention.
Thank you, Angeliki. Questions online? Someone will ask something? No? Okay. Obviously, also this presentation is very interesting, and it highlights also looking at the maps, a huge concentration, obviously, of risk, but not only for environment, but also for people, because I saw several similar situations also in Italy, in several parts that I know very well, where the risk is not only for the forests, but also for people who live in a very high risk zone. And in my opinion, this kind of study are not very well considered in civil defense, for instance, because the risk is very high. And, I hope that this on this kind of study will be considered and normally in the normal activity, because it's very dangerous for everyone. Thank you. Just a consideration, not a question. Thank you for considering this, and very interesting. Other consideration, questions? No? Okay. Thank you to everyone.
Thank you very much.
Thank you. Thank you.
This interesting session. Thank you, Anastasia. It's a pleasure to see you, and I hope to see you in the future, and also to Liliana, because this year we missed you. We both, but okay. I hope to stay together. Thank you to Felicia and Maria also for this other interesting presentation. Okay, now we have to go to the keynote, and no, we have coffee break later. The keynote. Okay. Thank you so much. Have a good day. Bye bye.
Thank you.
Bye-bye.
Thank you for having us.
Bye.
Bye-bye.
Thank you. Bye.
Sì, io sono una scheda. Ho visto il sede dell'Università dell'Università. Sì. Io lavoro con Guido Masel. Prossimo c'ero l'anno scorso, sono venuto a insegnare un corso all'università, cioè a scuola di Remote Sensing. Venuto con no, in una scuola, diciamo.
Sei il direttore sulla quindi Guido, Marcello, Giuliano Righetti.
Noi lavoriamo sulla produzione del data e non sulla creazione.
Sono professore di
ero sì, certo, ovviamente adesso no. Appunto dicevo l'anno scorso sera sono stato a insegnare a una scuola che c'è stata proprio da voi la Technology School.
Per caso all'interno del Master EOSAF fecero qualche...
No, all'interno del progetto dell'ASI.
Ok.
Ci sono state due scuole, una a Bologna e la seconda a Bologna.
Da dove viene? Tu da dove
Da
vieni?
Firenze.
A Firenze.
Ce n'è da via, credo.
Abbiamo come dire, una tradizione di fisica.
Sì. E io sono matematico, non sono matematico di genere. Per quello sulla creazione. Solo visto che c'era una...
Ma presenti in qualche sessione?
C'è il mio studente del PhD che ha presentato ieri.
Quale sessione?
Quella di Remote Sensing il titolo del workshop
Che erano organizzati i colleghi del CNR, Rosa La Saponara,
mi sa di sì.
Maria Danese,
Sì, c'erano due prende la quale potevano
c'era l'altra pure di Fabio Arantino, colleghi di
Però guardo
i vari. Sì, va bene, penso che la mia. Devo contare questa cosa della nostra sì.
Perciò
sì, era Advanced Computational Method for Experience Application con Luca Pirotti, Patrizia Capizzi, Mariana Muzzolino.
Quindi era un'altra, non mi ricordo.
Questa era un'altra, sì.
Sì, non era un'altra.
anche ci caffè.
Guarda.
Sì, sì. Sì, sì.
Il 8 hanno assoluto, diciamo, cioè, quello là per i quali siamo stati classificati come 08.
Sì.
E che cos'è? È un macrosettore, no? Come definisce il 08?
No, invece sono stati definiti, cioè l'area 08 è stata divisa in quest'area che si chiama architettura e l'altra che si chiama ingegneria.
08 architettura, l'altro 08A, 08B, che invece è tutto il resto.
Tutto il resto.
Di 08.
In cui siamo noi, Bizio, Marino, basta.
No, io no, sto preparando quello che dirò martedì, no? E ovviamente la giustifica di... Come si può chiamare? Gruppo disciplinare?
Ma non è un gruppo disciplinare, mi sembra scusa.
Come lo chiama la QQR?
Certo.
Vabbè, vediamo dopo, quando infatti quando non c'è. La famiglia non fa Paolo prima.
Ho preso servizio.
Ci vuoi fare
Quando ha preso servizio? Quindi a Fiumara, fondamentalmente.
Ha detto Fiumara. Ha detto Enzo che ti tocca.
Vabbè, io con Paolo io vuole raccordi in questo. Cioè, immagino come possa avere Paolo.
Paolo.
Io posso avere con Paolo, che non lo
Bene, sì, senti Paolo, oltre a farti gli auguri, ti volevo dire, tu hai visto che io adesso avevo già fissato un appuntamento per martedì come consiglio di direzione per la programmazione con i giovani. Penso che sia già lavorato del consiglio ordinario.